All right, here is part 3. I'll try to keep it as short as possible for this. Sorry, I really like these problems. We're going to look at here. It says AC is a diameter of the circle. The area of the circle is 289 pi units squared, and AB is 16 units. We want to find the measure of BC, and we want to find the arc measure of that arc BC. All right. I stared at this problem for a long time because I was like, I think this has to be a right triangle, but it doesn't tell me it's a right triangle. So how could I know for sure? Well, I figured it out because AC here is 180 degrees. Because AC is that length there is a diameter, meaning it's cutting the circle in half, meaning that arc measure AC is 180 degrees. Well, if that arc measure is 180 degrees, that means that that inscribed angle B, that inscribed angle that creates that arc measure, has to be 90 because it has to be half of that arc measure. And so there is my reassurance that this is for sure a 90-degree triangle. Now I have a 90-degree triangle. I know up here is 16. I know BA is 16, or AB is 16, sorry. I know it's a right angle. And I think what I can do then is to figure out the length of AC, I can figure out the radius and then multiply the radius by 2 to get the diameter. To figure out what that radius is, well, we know the area of the circle is 289 pi units. Area is represented for a circle by pi times the radius squared. That equation for this particular circle would give us an answer of 289 pi. Now I have an equation of the radius equation set equal to what the the area equation set equal to what the area really is. And now I can solve it for radius. So I divide both sides by pi. Divide this side here by pi. These pi's cancel away. You get r squared equal to 289. You square root both sides, and the radius would be, if you square root 289, you get a radius of 17. So AE is 17, but the whole thing AC would be 34 because the radius or the diameter is 2 times as long as the radius. So if radius is 17, diameter must be equal to 34. All right, now I have a right triangle. I know, I know 2 of the sides. I can find the third side by using Pythagorean theorem. So I get a squared from the leg that I don't know, plus b squared. B squared is the other leg, and the other leg is 16, so plus 16 squared equals my hypotenuse squared, which is 34 squared. And once I work this out, a squared plus 16 squared, I got to grab my calculator quick. Sorry. All right, 16 times 16 is 976. 34 times 34 gives me 1,100. 16 doesn't seem right. 1 second, sorry. Okay, never mind. 1,156. I think I screwed something up. 16 times 16. Yeah, sorry, not 976. 256. I don't know where I got that from. 256 here when you do 16 squared. I'm going to subtract over the 256 to the other side. So I take 1,156 minus 256, and that gives me 900. Square root both sides. A gives you 30. And that means that BC, that line BC, is equal to 30. Because really I called it A, but it's really BC is equal to 30 units. All right, so I know that that line there, BC, is 30. Now I need to figure out what this arc measure of BC is. Well, A is the inscribed angle. A is the inscribed angle that makes up BC. So if I can find angle A and I can multiply it by 2, then I can get that arc measure BC. So what I need to do here, we know that BC is 30. I'm going to actually use inverse trigonometry to figure out what that angle A is. And I think I'm going to do inverse trig here, and I'm going to do opposite over adjacent, and 30 being opposite, 16 being adjacent. And I'm going to do, because it's opposite adjacent, tangent inverse. And so I'm going to do the tangent inverse. The tangent inverse of my opposite, which was 30, over my adjacent, which is 16. That gives me an angle. If I do inverse tangent 30 divided by 16, that gives me a 61.93 degree angle. I need to multiply that by 2 though, because that's the inscribed angle, and I know that arc measure or central angle is always 2 times bigger than the inscribed angle. And so I take that 61.93, multiply that by 2, so 61.93, multiplying that by 2 gives me 123.86 degrees as that arc measure for arc measure of arc BC, and I make the arc over it. All right, we'll move on to the last one. We have a triangle inscribed in a circle at the right. We need to figure out what the measure of AB is. Really not too bad, actually. We know that the arc measure of BC is 112. We can figure out AC, that arc measure of AC, pretty easily because we know an inscribed angle. And then all we need to do is figure out that last part. So we'll take 360 minus the 112 minus our arc measure from here, and whatever's left is going to be AB. And so let's talk about that arc measure of the measure of AC. We know the inscribed angle is 65, so the arc measure is going to be twice as big as that inscribed angle. So 65 times 2, twice as big, and 65 times 2 gives me 130. So now I have 112 degrees, I have 130 degrees. Whatever is left up here, x, is my AB. And to figure out what that x is, we're going to take 360, the total degrees in a circle. We're going to subtract 112. We're going to subtract 130. And whatever's left is going to be our AB. And so we just do that in a calculator, 360 minus 112 minus 130, and we get 118 degrees for AB. And that's it. I know that took a long time for that problem. I probably should have shortened it now in hindsight, but I just like that problem. Like, if you go back and rewatch it, think about all the different things that I've really touched on in these videos. I mean, similar triangles, tangents, intersecting chords, inscribed angles, central angles, arc measure, arc length. There's just so much in here that I didn't want to skip over anything. So if you made it all the way to the end, I appreciate you, and I hope these videos were very helpful.